Okay, thank you, André, again for being the logistician for making this this seminar online working very well. So welcome back to everybody. Todo mundo sejam bem-vindos. Esse seminar vai ser em inglês. This seminar will be in English. So I have the great pleasure to introduce my colleague and friend Philippe Pasquier, who's French, but who's full professor at Simon Fraser University in Vancouver, in Canada, West Canada, British Columbia. And Philippe has a long history, although he's still young, younger than me, already in AI, various aspects of AI, various techniques, but for a few years, he is really focusing on the issue of AI for arts, and for not for the mass, but for kind of wide use, and so he will present various projects. So Philippe created the meta creation, so about this kind of, and to experiment and to evaluate, and to also evaluate the acceptability. We'll talk about that today, including that's one of the topic about these new techniques, including this new AI, deep learning based techniques for arts and for creation. So he's one of the the best suited person to participate in our cycle of seminars about AI creation and creativity and arts. So Philippe, without more words, thank you again for being here, and it's a great pleasure and honor to have you. And the palco, I don't remember the word in English, but anyway, the screen is yours.
The screen is mine. Thank you, Jean-Pierre. Thank you for the invitation, and hello everyone. I'm really happy to be able to address you all and talk a little bit about the work we do, and in particular today try to focus on acceptance and acceptability, and I will explain what it means and what I mean by that in a second. But first, let's put that in the context of the rise of AI. AI is already everywhere. AI is this idea simply of having machine automating tasks that are usually requiring human intelligence, or some human brain style intelligence to be achieved. And it's sort of a moving front, which since the mid 20th century really is allowing us to partially or completely automate tasks that are increasingly complex. And now there's two types of AI, strong AI and weak AI. And I won't talk about strong AI today, which is this idea of having sentient machines. It's something that is being debated in research, doesn't exist yet as far as we know in reality. Instead, I'll talk about weak AI, that is this idea of making machines that automate one particular task at a time and don't have a generic type of intelligence. So that's the context I will be talking in. And while usually AI is about automating rational problem solving, problems for which we have an optimal solution, we at the Meta Creation Lab are interested in studying the partial or complete automation of creative tasks, which are precisely those tasks for which there's no optimal solution. So we're looking into generative algorithms, and we've been doing that for over 15 years now, here in Vancouver, in British Columbia, at Simon Fraser University. And we're doing that across domains. That is, we're interested in whether the generative and creative pathways and workflows are similar or different when it comes to visual art versus music versus dance versus video games. So we're interested in all corners of creative and entertainment industries. So creative tasks are exactly those tasks for which there's no optimal outcome. That's the definition I give for that. That is, there is no such thing as the best graphic design, an optimal drawing, or a Pareto dominant choreography. So a lot of the tools that we usually use in AI to guide us toward a solution by trying to go toward an optimal approaching it anyhow, those tools typically don't really apply when it comes to creative tasks, which make it, from a computer science perspective, an interesting set of problems. At the Meta Creation Lab, we work on this idea of creative AI in an interdisciplinary framework. We do research creation, and so we provide and develop new algorithms that we publish and evaluate in scientific conferences. When those algorithms do work, we apply them with the industry to try to reach actual users. And then we also test those algorithms working ourselves with them as artists or working in collaboration with artists to derive some artwork. So I'll take a few examples of artworks and applications as I go along today. So the plan for today is I want to convince you that there's at least two main broad families of applications that we're going to see, and we already see, unfold from the rise of AI and creative AI in particular. The first family of application are going to be real-time, online, embedded generation. This idea that an agent or an AI system generates a particular content in real time to fit a particular interactive and interaction at a given time. The second family of algorithm I'm going to look at computer-assisted creativity algorithm. So that is the idea of having some sort of workflow in which a human creator is working with the AI. Sometimes we say co-creating, working with the AI, often in a back and forth, in order to generate some content and some assets. So I'll talk about those two families, give some examples, and then we'll talk about how do we evaluate those algorithms, and we'll talk in particular about the acceptability of these systems. If these systems are to become everyday systems and are to be embedded in pretty much any interactive experience you can think of, then it's probably a good idea to look at whether the creators and the people from the creative industry accept those systems and are at peace with those systems being deployed, and likewise for audiences, if what is the acceptance for those technology on the audience side. And so we'll talk about early results in these areas, and then we'll conclude with listing some challenges and opportunities that creative AI is bringing to us. And there's no shortage of these. If you follow the news, there's barely any day without some sort of advance or reflection on the current advances in the field. So let's start with this first family of applications of creative AI that I think are going to become and are already becoming pretty ubiquitous. So embedded real-time generation. This is often the notion in AI of agents, a system that can react in real time, in context, sense its environment, and act in its environment. In the case of generative AI, it's all about generating the right content at the right time. A good example of that, something we've been working on for over a decade now, is the notion of musical agents. So that's the idea of an artificial agent that would play the role, if you wish, of a live musician on stage. But there's all sorts of other intelligent agents for which this would be the case of being real-time and online, ChatGPT being a recent example that I think everyone knows. So we've been working ourselves on architectures for musical agents. Typically, the type of musical agents we work with are based on machine learning, and so we feed them music. Here we have Masom, an architecture based on a self-organized map. Masom will listen to whatever you feed Masom with. In fact, a lot of musicians get trained by listening to music. In fact, if you never listen to music, you probably won't even imagine what music is. And it's not the case that a human born on an isolated island will become Beethoven. Music is a social construction, and a lot of being what it is to be a musician is to have been exposed to a lot of music. So of course, to get an agent to play music properly, it makes sense to train it on existing music. And we see this idea of corpus-based machine learning throughout the presentation, because this is really the core technology that is powering the AI of the day, deep learning, as well as other approaches. So here we're using a type of neural network called a self-organized map. The agent is listening to music and segmenting sounds and classifying them. Is building a sound vocabulary, if you wish, to play with. And for each album that it's listening to, is also building a temporal model. And being, if I was, when I model this artist, I'm now being able to construct the probability distribution or the time series and the time sequence regarding that artist aesthetic. In other words, given what was played before, what sounds am I going to play? Given the sequence of sounds that have been played before, what sounds am I going to play next? And so the idea of the agent is it's capable to do that on its own, but it's also capable of doing that along with live musicians. And so in the case of here at MUTEC in Montreal, in a concert setting, I play myself with my software, and this is the context of improvised experimental music. I play Kivench in the middle here plays, and then Masom is listening to what Kivench is doing, what I'm doing, what Masom was doing before, and trying to predict, given those three things, what should I do next to still fit the style that I have been asked to emulate, because Masom is basically emulating the style of the composition he's been exposed to. That's called style imitation, and it's pretty competent at doing that. The show that we did put together at MUTEC was called Revive, because we were reviving dead composers. In this case, the agent was trained on the CDs of dead composers that I always wanted to play with, but there's no chance I will. Composers and musicians I wanted to play with, but unfortunately are no more. And so it was also a way to, in a semi-provocative way, to try to point at the fact that with AI, there is those possibilities of rendering existing static linear material, non-linear and dynamic again, and play with it. So here is an example of Masom generating music trained on the work from a Turkish composer called Mehmet. And here the agent is playing alone, but it's sending signal and synchronizing with a number of visual generation systems. And you can see that the synchronization between the sound and the visual is such that in real time, it would not be easy for a human to do that. All right, so capable of playing and generating music alone or interacting in real time with a musician. We've been building up on this line of work, got some best paper awards at the Conference on New Interfaces for Musical Expression a few years back, by getting this agent the possibility to also take feedback, for example, during rehearsal. It's very nice when you improvise and work with musicians to be able to tell them, oh yeah, let's do more of this, let's do less of that, I like this. And then working on different behavior for this agent. Is it an agent that is leading the pack when it comes to the music? Is it following? Is it mirroring some of the musician? Is it trying to be complementary? What is it trying to achieve as an artificial musician? So this is one first example of real-time generation, trying to generate the right content at the right time for the interaction and the experiment. Another example that we've been working on is in the field of movement generation. Here we do motion capture of actors and dancers, and we're capable not only of then generating any movement with their movement style, but also being able to interpolate between the movement styles of different performers. And if you are, like we have a lot of them in Vancouver, a film company, Netflix and Amazon are shooting here in Vancouver, a video game company like Electronic Arts, or some of the many hundreds of video game studios here in Vancouver, and you need hundreds or thousands of characters for your game, you won't be able to afford to motion capture hundreds or thousands of actors. And so this idea of being able to explore latent space and generate new movement style on demand is really appealing. And that's exactly what's happening here. And we can control the perceived emotion of the movement qualities. We've been working on capturing movement qualities. Here we're looking at valence, how happy and confident the agent is, and arousal, how relaxed, calm, and or excited the agent is. And then we've been working on movement generation in a multimodal context as well, still working actually on dance generation. Here is another early example of GrooveNet, which is one of the very first, if not the very first, deep neural network for dance generation condition on music. Here, this is a case of generative music, actually, that is making this little virtual agent dance. I'll play an example. And then you see here, it's dancing on the rhythm. It's working well in terms of real-time generation. This is obviously a video capture of it. But there's also part of the movement that is sort of non-human. And that's something that we will see over and over with those generative algorithms. Sometimes it's about style imitation and the suspension of disbelief, and it has to look realistic, as in human-like type of output. And some of the time, we use them for their inherent aesthetic. Some people talk about the neural aesthetic as a new emerging aesthetic and cultural sort of subculture with its own parameters and its own aesthetic. So these are all generative systems that react in real time to the environment. They are interactive systems, and those interactive systems do call for generation. So why would we remove the human in the loop when we generate animation, when we generate music, like we saw in those examples? Well, there is many reasons, but some of them have to do with the move from linear to interactive media. As I was mentioning, you might want hundreds, if not thousands, of characters and movement, and it might become too expensive to create those assets manually. If you develop a linear media, write a book, make an album, make a film, and you have a team of 200 people, like for a movie for Pixar, for example, it makes sense that you have humans do everything and every second be looked at by professionals. And that has been the model of media production, mostly linear media so far. But when you're developing interactive media, interactive systems, some systems for education or for entertainment, such as video games, and you have open worlds like the World of Warcraft, where you have 11 And when it comes to real-time application, there is this promise that that comes in a way with AI, that those computers will be, that our computers will become smarter and will be able to help us by delivering the right content at the right time in any interactive application. And so this is the case right now for online applications such as artificial agents and virtual agents, and this first family of applications that I wanted to talk about. One of the promise of AI there that has never been really realized so far is this idea of adaptive experience, that not only the system would be capable of quality interaction and generating the really good quality content, but also that the system will adapt to its user. And that's really motivated by this idea of flow in psychology. In other words, if you think of an educational experience, or if you think of a video game, any interactive experience, if it's too easy, not challenging enough, then I'm going to get bored and you're going to lose me. If I keep on losing, this game is really hard for me and I can't make any progress, then I'm going to get discouraged. It's too hard for me. I'm going to give up. You need to keep me in the flow zone. You keep me engaged with the interaction. And in order for that to happen, you need to sort of know what are my boundaries in terms of this flow zone. And the flow zone will change for everyone. Maybe I'm a slow learner when it comes to video game, and you have to generate experiences that are just have small increments of complexity and challenge. While maybe someone is a very fast learner, someone younger, and you need to challenge them by moving the flow zone quicker to higher challenges zone. And so it's only by following and tracking a particular user that we get ourselves a chance to give them the right experience. In education, for example, it's quite clear that if I could do one-on-one teaching, it would be better because I can match the students' level at any given time. While right now at the university, I have to teach hundreds of students at a time because we don't have the means to have a given faculty for each students. And so we have to make choices. Do we teach for the best students? Do we teach for the worst students? Do we teach for the average? Socio-political choices have to be made here. We think that with artificial agents and the rise of this generative AI that can work in real time, we'll be able to change things quite a bit when it comes to interactive systems. So we've been working to illustrate what it really means and how we make these ideas concrete on game level generation for a long time now. And we had some award-winning system that were literally doing exactly what I just explained, tracking where the player is at and generating levels that have a flow and a rhythm within the level, but have a tension curve that sort of stay within some boundaries that keep the flow for a given player. And we've been evaluating those approaches to game level generation, personalized game level generation, and adaptive game level generation, if you wish. And we see that it does improve the engagement indeed and the pleasure for the player. Now, once you have a level and you actually know the tension curve that the player is going to go up with, the more jumps you have to do, the more enemy you encounter, the more the tension rise. Then it's, of course, a great information to then make music that follows that tension curve and have music that really illustrates what's happening in a game at a given time. So we did some experiment as well on showing first that music matters in interactive experiences and in interactive systems, because we have a lot of results in the cognitive science literature about music being very important when it comes to cinema and animation. Often when you cry in a movie theater or watching a movie, it has to do with the music. If I remove that music, even if the plot is very sad, the music is really the trigger for the amplifier for the emotion. While when you play a video game or you're into an interactive systems, you're cognitively busy, maybe more than when you're passively watching a movie, and you're sometimes physically busy. So is it the case that music still matters? And so we made empirical experiments using that, yes, actually, it does still matter. Then we developed our own corpus with valence, arousal, and tension this time, and developed systems to generate music based on what's happening in a video game. And here we really have, in a way, an agent, the playground model, that is watching the game and analyzing the emotion from the point of view of the player. So this is like a player's good friend who is ruling for the player and analyzing the valence, the arousal, and the tension, how positive and negative what's happening in the game is, how calm or eventful it is, and how tense it is. And those curves are then informing music generative and adaptive system to make music that really reflect the experience of the player in the game from the perspective of someone who is emotionally bound with the player. And we did show indeed that this is allowing emotion, perception, and immersion and enjoyment for the player better than simply adaptive music without generative music, and certainly better than no music at all. It actually doesn't do better than linear music, and that has to do with the fact that this generative adaptive system didn't have the musical quality as its output that professional composers would actually give to the music. So we also need to get those systems to be human competitive before they really are as effective as linear work by humans, which I'll talk about the humans in the loop and out of the loop a little bit later. Finally, final example of generating the right content at the right time for a user in the context of an interactive experiment, which I believe to be the first big family of creative AI applications, is an app that came out from the lab, but that was removed from the App Store, I think, last year, but was pretty successful for a few years, called Aula. It's a soundscape generation and music generation app in which you choose your state and what state you want to be in, and the system is going to generate binaural beats, soundscapes, and music to try to bring you to that state. We're trying now to work with students on augmenting this type of approach with biosensing, signals being used by the AI to inform the generation. In other words, measuring if you're relaxing and trying to generate signal that would relax you. This is the idea of functional music generation. And in general, I think in the domain of creative AI and generative systems, we're going to see a lot of that type of approaches of functional generation. In fact, we know that from scientific studies that music therapy works. And again, we don't use all of us music therapists because it's expensive and because there's not going to be enough music therapists, but everyone has a phone or a computer. And so therefore it's really enticing, this idea of eventually porting those approaches to the digital world. All right, so these are really examples of this first family of approach of online real-time generation. This idea of serving the right content at the right time in a way was already present for a long time in interactive systems. That's how the internet works. That's how a search engine works. That's this idea of recommendation. You ask the system something and it tries to serve you the right content, recommend you the right content at the right time. But the content itself was typically human-made. Now we're moving into some of that content being at least partially generated as well. And so with this generative system, we just go one step further here and increase the variety, the richness, the diversity, and maybe the appropriateness and the specificity of the content that is being served. Well, sometimes online generation is not an option, or sometimes, as I was mentioning in the case of music for game, the quality of online generation is not good enough. In the case of music for game, it's not just because the generators are not good enough, it's because there's only that much CPU and resources left in the game engine to process the music, and generative music can be very expensive, and so you have to make sacrifices. And so very often there's also offline content creation, not just online content creation, that is important. And so that is really the transition to the second family that I want to talk about today, which is offline content creation, this idea of computer-assisted creativity. And here we talk about the creative industry, which for the most part is spending their time in front of computers, in front of creative softwares, the Adobe suite of this world, clicking on buttons to get things done, often to create assets. And so the second family of approach of creative AI is really to cover these co-creative or computer-assisted creative applications. So I start here with computer graphics. We worked with my colleague, Steve DiPaola, who was leading this work on style transfer, where you could select a number of paintings from a known style like Rembrandt, or a style that you decide through a set of pictures, and then the system will learn how to transfer any photography into that style. So this is me in the style of Rembrandt and me in the style of Horton. That was used later on. Similar systems were used, and we were giving the user the power to train their own style and then apply it. There's an app still in the App Store from a colleague from the Generate company, based in Toronto now, that was released in 2017, and we had some success with that type of work. This idea of giving those creative tools to the hands of users has been since then dramatically ramping up, and I'm sure all of you have heard about prompt-based image generation, whether it's GAN-based or diffusion-based, like Stable Diffusion or DALL-E type of system. There's been really a massive wave and some sort of enthusiasm around that. We did similar prompt-based work already a long time ago in the field of computer-assisted sound design. So what has become very popular was in fact not that new. And as early as 2012, we were publishing systems in which the prompt-based generation was already operational, although in the context of sound design. So here the idea is to generate a soundscape. And so you enter a prompt, for example, a question, the kids are playing in the park on a Sunday afternoon, let's say, and the duration of the soundscape that you want to generate. You get to draw the curve for valence and arousal. Maybe the kids are playing in the park and I want it to start sad and finish happy, and start eventful and finish calm. Then when you generate, the system is gonna find sounds, segment sounds, and we have good papers on background and foreground segmentation and classification, which are universal categories. Is a sound a background sound or a foreground sound? And then we layer those background and foreground sounds, recognize the emotion, mix them so that the cumulative emotion match this curve, which is not an easy feat, and eventually do either an audio rendering of this proposed sound design, or you can download the timeline in your favorite digital audio workstation in a sound composition and editing software and work with it. And so this software does in a few seconds hours of work, like finding on your hard drive among the 1,000 sounds that you have as a sound designer. Here there might be 50 or 60 sounds that have been found and put together. You might not like them all, and when we evaluate that system, we find that it's not as good as a professional, but it's so much faster that a professional or an amateur beginner interacting with it will be able to work in a more efficient way and be more efficient. So here is an example of the system at work. If you ask for a waterfall in Thailand, you might come up with a mix like this one. And the system is available online, so you can try it for yourself. There's several versions of the system online at the address here. But you can see that if I don't like a mix, then I can just press generate again, and the system is non-deterministic. It's going to give me a different mix, or I can change my request. And so that's this idea of computer-assisted creativity, where a creator, sound designer, would interact back and forth with the generative systems so as to converge in a way toward the generation of the desired asset. Here is an example of what a city in the bush might sound. So here, very simply, the system has been finding sounds of recordings of bushes and recordings of cities and putting them together onto a timeline. And then if you give that to creatives, sound designers, musicians, or artists in general, they will very quickly appropriate those tools and eventually use them in ways you didn't foresee. For example, they might make requests that are very abstract and for which you don't know exactly what the soundscape or the sound design should sound like. And then the tools then become a creative instrument, sort of an inspiration machine. Here is how a quenching rain drenched my burning head could sound like. All right, so that's computer-assisted sound design with prompt engineering from 2012. So that's like 11 years ago already. More recently, we've been really focusing on computer-assisted composition, mostly because for once we got an algorithm that really worked very well at a human competitive level. Not surprisingly, it's a transformer architecture that we trained on symbolic music generation. So here we're talking about the score. We trained the system on MIDI and scores, so symbolic representation, not on audio, not on sounds themselves. So it's really a composition machine that is capable of giving you musical patterns, but not sounds for them. It has 16 bars of attention, which is one of the main limitations in the field at the moment. And that has to do with the fact that we want the system to run on a personal computer. But it's been better and more versatile than most of its competition in the context of music transformers. It's been one of the earliest one as well. And the reason why is because the reason why it's working well is because it's trained as often with deep learning on a large data set. And we released in 2021 the Meta MIDI data set. It's 500,000 multi-track MIDI files, and it's an order of magnitude larger than all the other data sets. You can find it on Zenodo for those who are interested in it. And so we trained a GPT-2 architecture basically with our in-house encoding and tokenization and a couple of tricks. And here is an example of what the resulting model can do. And mostly this model works by in-painting, and I'll explain that a little bit more right after the example. So as you see, the sound is not what's being generated. What's generated is those patterns and piano roll, and then it's played by a mediocre synthesizer. It's called a MIDI synthesizer. that allows you to hear the sound. But what just happened here is we saw some examples of what the system can do. What the system can do is it can generate music from scratch. Typically, you would not generate from scratch because the system knows so much music that you can end up anywhere. You can end up with medieval classical music, or with contemporary jazz, or with heavy metal. So often you will use an existing musical context as a way to prime the system, or you would condition the system on asking for a given style or given composer and things like that. But the system allows you to generate things from scratch, to otherwise add new tracks. So here, for example, you could add a new track and choose an instrument, maybe a piccolo, and the system will make sure that musically it works with what's already existing. You can regenerate a track. I didn't like what you did with this piccolo, do it again. You can decide to regenerate only some bars. I like what you did, but I don't like this bar, and this bar, or this block here. Please regenerate that. And you can also generate longer full track style bars and generation, because even though the system has only 16 bars of attention, you can have a sliding window, and if the context is encoding the structure of the music, then you will keep that as well. There's a number of controls that you can condition the generation on, and in fact it's really a big topic of an area of research, is how much control do we need to give to those systems for the user. And is it the case that the beginner user and the advanced user should have access to the same set of controls? Here is a list of the control. I won't go through everything, but there's low-level musical type control. Some of them are pretty intuitive: music, not density, not duration. I want a lot of density, short notes. I want low density, long notes. So the type of texture, musical texture I can generate. And some high-level features as well: musical style, redo me this bass, but more in a disco style. Again, we could condition on artist, but that would get us possibly into some copyright issues. We'll talk about that in a second. Spotify-like attribute, because our data set is linked, although it's MIDI files, is linked to audio rendering of those files and audio version of those tracks through the Spotify API. So danceability, energy can be controlled. Valence arousal tension, the music. If you generate music for film, having control over the tension is really important. And then we're working now on models for interpretation, adding micro timing, velocity to the notes that are generated. In general, it's a really, really, this multi-track music machine is a very competent composition assistant. Here is an example exemplifying one control, which is the control of density, in which we regenerate a drum track, I think, with a different density. And then after that, there's a little bit of adding some tracks on top of some existing composition. Let's see. All right. So those are examples of the model being demonstrated. Because the model works so well and is quite versatile for computer-assisted composition, then we've been working with the industry. We're working with Elias, which is issuing from Sweden software for game music composers. And so game music composers have a lot of variations to make. They write a theme maybe, and then they need many variations of that theme, for when it's calm, for when it's energetic, for when it's sad, for when it's happy, and a lot of variation. And it happens that the model is really good at making variation. We saw some example of that, by which those are even new features that allow us to make variations where you randomly pick, let's say, 50% of the bars and then change them. Then that's going to be a bigger variation than if you change 30% of the bars, which, you know, and you can change up to all of the bars if you want. The order in which you do those changes, the amount of bars you resample at each time, all of that is going to have an influence on the output. We also been working with teenage engineering who are making synthesizers. And if you know about programming patterns into synthesizer, if you're not really good at playing yourself and you're not a composer, it's typically time consuming and not straightforward. And so while users really love playing with the sounds, if they don't have composition background, it would be really nice as an inspiration machine to empower those users by giving them access to the multi-track music machine, our model, embedded in the apps that come with a synthesizer. The models, those transformers don't run on the hardware so far. You sort of need a CPU or a client-server sort of interaction, and then the user can then generate a pattern. Here are examples of electronic music made with some teenage engineering synthesizer using our model. Right, so that's an example of house music. Yeah, that is available on Spotify if you're interested. And then another application of the same system is our online interface, which we're using right now, and we're onboarding people. So if you're interested in trying MMM in something that is better than a notebook or the code book of Google, you can check this QR code here and onboard yourself into using Calliope. You get them to load some MIDI and make some generation. Oh yeah, here is an example of Calliope at work on some making some variation from Mozart here. Oh, I'll play the video without the QR code. So we made a variation. Now we're going to add some tracks. All right, so that's Calliope. And in Calliope, we did enroll a number, not all, a number of the controls I talked about, density, minimum polyphony, maximum polyphony. So you can stream the MIDI to an actual synthesizer if you want it to sound good, or to your favorite digital audio workstation. If you have a synthesizer with 3 voices of polyphony, you don't want the system to generate 4 voices, for example. Note length also has a range, or you can let the system decide and choose by himself. And sometimes the system will make the right choice given the music that is around as well. And you can choose the instrument. So when you ask the system to compose a bar using an electric bass style, then it means what's going to be generated is going to be within the range of what electric basses do and within the type of stuff that electric basses can play. Typically, for example, not too much polyphony. there's new, with those type of computer-assisted composition system, you can see a little bit the back and forth and how someone would generate new assets that way. There's also entirely new, completely new type of features that are possible. Here, I'll point to the fact that we have a variation engine where you can just tell the system, hey, I selected all of those tracks, now resample 100% of them or 50% of them, do that two bars at a time on 4 tracks at a time. So a block of 2 by 4. Or do that 3 bars at a time on 1 track at a time. And you can ask the system to batch generate and to do that, to do those variations, not 10, but hundreds of times if necessary. And we have an award-winning ranking algorithm that also allow you to tell, hey, make those variations of this track and now rank them all according to the original, or rank them all according to this other track. And then I go down the list and I decide how far of a variation I want to the original and which variations I like more or less. So these are brand new sort of features, because obviously if it was not a machine that would generate all those variations, nobody is asking for 100 variation of a given composition because it's way too expensive to generate. It would take a lot of time. And so that's all embedded in Calliope, and you can play with that. Beta testing, so be kind with us and report bugs when you find them, because we're still trying to improve a little bit the system. We're not product makers really. We are developing these systems mostly to conduct research. Now we're also interested in reaching larger audience, so we're working on an Ableton Live plugin that we hope will soon be available. Being the most common music software out there with 6 million licenses. If you're interested in trying in Ableton, email me, because we are beta testing that as well now, and we hope to release publicly this fall. I was talking to the good people of Ableton quite recently. I gave a talk in Berlin, and they told me that I should release, so I will do so. I wanted to point out we use as well our system ourselves. And we entered twice already in the AI song context, which, if you don't know about it and you're interested in music and generative music and creative AI in general, is a great annual yearly contest in which a number of musicians, bands, not just researchers and academics, are entering music of a variety of styles. There's a lot of diversity there using AI tools, and you would be really surprised the diversity of AI tools that are being used, and the even larger diversity of ways in which they're being used. Artists are being very, very creative, and from lyric generation, whatever creative part of music making you can think of, there is a tool for that for sure, voice synthesis, etc. Here is a quick example of our entry from 2021 made with our systems as well, just to give you an example of pop rock, surf rock in a way, in this case, so a different style to exemplify the versatility of this type of systems. Right. So that's the second family I wanted to give examples of: computer-assisted composition, but in general, computer-assisted creativity. And I gave some example in sound design, in music, in sound synthesis. We saw that in visual art, photography, animation has become really popular. But literally, you can think of any creative task that could be achieved in a computer-mediated fashion. And a lot of the creative industry right now is people in front of creative software making assets manually. Any of those creative tasks you can think of, there's already an AI system for it. Cocktail making, fashion design, you name it, there's an AI system for it. And so if we are to augment every creative software with embedding in them the generative AI system that we can interact with, and if we are to put those AI assistants and assistants everywhere, then it's important to start evaluating those systems and to look at many dimensions of the systems, including their acceptance. And so now I'm going to talk a little bit more about evaluation and acceptance in the third part of this talk. Evaluating generative system, creative AI, and meta creation is not easy. But there's two big types of evaluation, really: informal evaluation and then academic, more formal evaluation. In the informal evaluation, we have the fact that an artwork is ready or a system is ready when the author, artists, designers, computer scientists decide it's ready. And then eventually peers, colleagues can give feedback, experts can give feedback. The audience is a real world type of feedback and evaluation. If you release an album, people buy it or they don't. If you organize a concert, they come or they don't. And then the media, the critics are important to get feedback. And we are really interested in user experience and acceptability and feedback from actual artists. In fact, as I exemplified already, we've been working with artists relentlessly, and we got some grants from the Canada Council for the Arts a few years back, working with 5 North American artists on using some of our computer-assisted composition tools to make some music. And so an album is ready, actually, is being pressed as a vinyl, I believe, and will be released later on this fall. And we've been working with other selected artists. If you're interested in working with us using our tools, let me know. We'll be more than glad to give you access. So that's sort of informal, qualitative, experiential, artistic, research creation, practice-based sort of evaluation. But what we're interested in academia is also more formal, scientific, academic world evaluations. And there's both empirical evaluations as well as theoretical and analytical measures. And when it comes to the evaluation of co-creative interfaces, there's very many dimensions why one might want to evaluate. So let's look a little bit at some work we've done regarding the creator stake. Here, we're not going to look at the evaluation of the quality of the output of the system. We'll assume the system is human competitive. There's already been quite a bit of work on showing that and establishing that. So I won't talk about that so much. What I will talk instead is about the human-AI interaction with the system. So this is fairly fresh work presented earlier this summer at ISCAI, the Joint Conference on AI in Macau. And it's collaborative work with Steinberg. Steinberg is one of the main music software company, and they're interested in the multi-track music machine model and interested in what impact that will have on their user to embed that model in their music composition software. And here we're not just interested, as I was mentioning, into the competence, the quality. Is the system perceived as reliable, competent at its tasks? Not just the efficiency, does it allow saving time and effort? These are really important for it to become a product, for sure. But we're more importantly, in a way, interested into the agency that it gives to the creator, to the musician, the level of control and the expressivity that comes out of using that system. Is it the case that you feel you have enough control to generate music that you feel is yours? Do you feel the music that comes out of that interaction and that co-creative process is your music? Do you feel it's the machine music? You've been guiding it and making requests, but it is not your music, although you might like it? Or is it a collaboration? And even one level deeper in the experience, looking into the phenomenology of using that system. If you have been a user of Cubase, the software in which we put the Steinberg software in which we put our generative system, what does it feel to you if you've been using this software for 10 years to have this new feature here? And what is the subjective felt experience of composing with that system versus without that system? So we started, we're not done yet, really, truly. We're working with Steinberg on a second study now, and we have a third one internally in the lab plan, but we're starting to work really on those questions. And so first thing first, we embedded and developed a little plugin, very minimal, with one parameter, which is like temperature, which is whether you want the system generate to be conservative or to be more wild. In a way, you control the entropy of the generation of the system. So we embedded the system so that people can generate in Cubase. They can still do all the in-painting, add new tracks, resample tracks, resample just a few bars, select the instrument that is going to be used, generate drums or one of the 120 MIDI instruments. And then we proceeded with a study starting with expert users, 18 expert users, both professional, people who make a living out of using Cubase, and other expert people with good experience in using the software and in music composition that are enthusiasts. And then that was a 9-week experiment, so pretty longitudinal, because we wanted not only to have a 1 use, 2 hours in a laboratory and you get to fill a survey, but we wanted to see if repeated exposure and trying different tasks would make a difference. And so we have 3 tasks: an arrangement task, you have to add 3 tracks to a 16-bar 4-track motif; a variation task where you have to make variations of an existing composition; and an original composition task in which you can start from scratch or start from seeds of your choice. Maybe you start with your music and you're making variations on your own compositions. For each of the tasks, there was 2 weeks, and then there was a usability with a standard usability testing measurement here, and then an acceptance measurement. I'll talk about it in a second. And then after all that, we went through the computer support indexed and some qualitative surveys for user experience. So that's the structure of the study. What's sort of new in a way here, although those tools and those instruments are not new, that's something that is used in the software industry, but in the product industry in general, the notion of technological acceptance. How do you measure user acceptance? And here is an early model. It's been refined in the 90s to much more complex cognitive model. But really, the basic idea of the technology acceptance model is stating here that the success of a system in terms of the user intention to use and reuse, and therefore actually use the system over time, has to do with 2 types of attitude forming perception: the perception of usefulness of the system and the perception of ease of use of the system. And that would condition the attitude, positive or negative, toward the system, which in turn will influence its intention of use. So it's really grounded into a psychological theory here, and the model has been extensively used to assess technology and their potential. And so when we do the measurement, in our case, the paper has plenty more measurements of all the other dimensions. What we find, though, here on the right, is that if the tool would be available for their work, then those composers predict that they will use it on a regular basis in the future. And in fact, the professionals agree even more so with that statement. And so what we found overall, to summarize, I invite you to read the paper if you want to know more. There's a lot of results in that paper. But we found throughout this study that MMM Cubase, the name of that plugin, is a usable computer-assisted composition creative software for multi-track music composition. We show in the study that it has provided decent user experience with good creativity support. It was shown that it lacks expressivity and control, and that makes a lot of sense because these were expert users and professional composers, and we just gave them 1 slider. And in fact, we could have enrolled all of the control I talked about for the model earlier on, and they would probably have wanted that way more because they understand those controls, and it would be useful for them to be able to, in a way, talk to the system in a more expressive fashion and guide the system in a better way. It was found overall that the tool has a good technological acceptance and a pretty strong self-predicted future use, which is really good news for Steinberg if they want to enroll this other product. But it's also informing us vis-a-vis our study results. In particular, I mentioned the notion of authorship. And here what we saw when we look at the qualitative results and when we listen to what the composers did and we talk with them about it, is that the system is viewed as a source of inspiration. In fact, maybe because they didn't have enough control to fine-tune their request, they really used it as a way to like, hey, what if I had a marimba here? Or can you make me a transition between those 2 parts? So you erase all the, you make space and you ask for the missing bars in between. It's like fill the blank in music. And they would take those outputs, generate a few options, and then eventually, because they're composers, because they're proficient, they would heavily edit, if not rewrite, the output completely. So they overall felt that they maintain authorship over the final results. And that's really, really encouraging, because that is definitely something that is important. And it turns out it's not something that is important only for the creator themselves. I would hypothesize that it's something that is also important for the audience to some extent. And that brings me to the second dimension of acceptance studies that we have been looking into so far, which is the evaluation of the creative AI generated content by the audiences. The audiences, can they tell the difference between machine generated content or not? And if they cannot, is the fact of being informed that something has been machine generated or created by AI will change the perception of it? So that is the question, in a way, of the bias for or against computational creativity. And we'll talk about that in a second. But first, discernibility is lost, and that has to do with the quality of the generative systems. The current generative system, I think I convinced you of that, to some of those examples, generate content that humans can't discern or tell apart from human-made content. And in fact, those musical Turing tests are equivalent or improvement over it, because in fact, we can do better than Turing tests when it comes to music evaluation or creative evaluation. I won't get into that, that's a research domain in itself, those evaluation methodologies. But for a lot of them, we do pass those tests, and people cannot tell apart a composition made by MMM and a composition made entirely by a human. So, and for the task for which human competitive quality is not here yet, it's probably on its way. And so this is really raising the question of synthetic media and deepfakes. And you saw that there's really now some work being done by government to try to start regulating this, maybe having a logo, being able to tell people, hey, this is made by a machine, this is made in collaboration with an AI, or this is made by a human without using any AI. And there's a variety of possibilities there. This is an example of a paper in which we do show that people can tell apart machine-made music and human-made music. So people can tell apart, but they need to be informed. And if they are informed, then does it make a difference? And that's the topic really of the bias against AI-generated content, the implicit or explicit bias. And this idea that computer-generated artifact will be often judged to be less interesting, valuable, or less creative than human-generated ones. There was already analytical evidence that such bias could exist. In fact, David Cope reports in his book, when he talks about his experience in musical intelligence in the 80s, that it was virtually impossible for him to find an orchestra to play otherwise really good composition that he would have made by developing the AMI system and using it. The conductors and professional classic music orchestras were refusing and sort of shocked by the idea that they would have to play machine-generated music. Now, concretely, in terms of studies of that potential bias for or against computational generated content, there's only a handful of papers. We have 7 here. That's 8 with the one I'm going to talk about right after. And I think there's 1 or 2 more recent ones that I've been looking at recently. And I actually changed my mind on the conclusion there. The conclusion of the meta study on the bias is moving quick, because we didn't find much in early studies. In particular, when it comes to music, we have very little studies showing any effect. But for visual art, we now have a little bit more work that is showing statistically significant effects with an interesting effect size that is showing that maybe there is a bias, an explicit bias against computational creativity. The type of experiment we do to show that are interesting and they involve deception. Is typically you do a pre-study showing that humans can't tell apart the composition made by the machine and the one made by the human. Here, the compositions in this particular study that we published this summer are made by MMM, a multi-track music machine, and then the human composed one are just selected from the corpus. So here is 2 examples. So there are short excerpts as well of multi-track compositions. And often we would take excerpts from the corpus randomly, and then we would resample all the bars in a random order, and then get this variation, maybe keeping one of the track, like the rhythm, similar. And then those would be matched in pairs of computer and human-made music, and then the participants are ranking those pairs, because ratings doesn't really work for aesthetic evaluations as much as ranking. Ratings are overrated. It's a great paper explaining that in terms of statistical instrument. And they evaluate all of those pieces, and then there's a revelation phase in which 2 different groups are given, for one of them, the real information about which piece is computer generated or human generated, and another group is being lied to. And we give them false authorship information, which allows to really test the explicit bias, the bias that even if, in fact, this is a human-made composed music, then if you still think that when I tell you it's made by a machine, you don't like it as much as if I don't, then it's for sure has nothing to do with the music. It's really your bias speaking. So this is the type of way in which those experiments are being run. In our case, and for music, once again, we didn't have any statistically significant result. We had another hypothesis in the paper that a higher level of computational literacy would have a lesser bias, but that didn't hold either. The idea there was that people who know how to program a computer know how much work there is behind a generative AI system and behind even using those systems, because in fact, nothing is really generated from scratch by a system, except in the evaluation experiment, which is a bit of a problem, actually. But we find that that it was not the case, that people who know how to program computers didn't have more or less of a bias, because we didn't find a bias in the first place. But overall, here, we can see that those studies around the bias, they sort of look at the acceptability of the fact that it is partially machine generated by the audience. And why the audience can't tell the difference, it seems that at least in the domain of visual art, it's unclear whether the bias truly holds and under which condition it holds, and more work is really needed. But it might depend as well on the medium. Like music, our musical perception quality is probably not as refined as what our visual cortex gives us when it comes to visual art. And in a way, we might be much more demanding with visual art than we are with music. Visual art is also often more representative, while music is, by sort of definition, a bit more abstract. Or it might have to do with specific communities. We try to look at the community of people with computational literacy and people without. We didn't find anything in the case of music, but maybe in the case of visual art, it would be different. And in fact, Bob Sturm and his team found that in the case of specific communities and musical style, like Irish traditional music, then there was an actual bias against AI-generated material, independently of the quality of the material. And as I mentioned briefly, there is also a problem, fundamental problem with all of those experiments, which is this idea of unconditional generation from scratch, that is testing just the model generation without the interaction with the human creator, is not a representative use case in general. And in fact, that co-creative approaches is what's being used and what will be used instead. And there's in fact always still a human in the loop, if only often a big team of humans to program the system, train the system, make sure the system work, test the systems, and fine-tune the aesthetic decision that makes a particular system output in a particular context work or not. So in a sense, not only computer computer-generated content is typically not discernible, but also nothing is actually 100% computer-generated. Nor it is the case that the things that we say are not AI-generated, they're also usually computer-mediated. In fact, it's very hard to make artwork fully without computers nowadays. Unless you're in traditional visual art or craft, everything is computer mediated. Even if everything is analog in your music, you go into a digital recording studio, and if you want to stream it, then things have to be digitalized and mastered, and etc. So creation is increasingly computer mediated, and in that sense, these AI tools are just coming up to take advantage of that, since people are already in front of their computer. And those are my last part for this presentation today, for the next 10 minutes, to talk a little bit more again about the pros and the cons. The embedded generative system, the first family I presented, they have the potential to provide the right content at the right time and enhance any interactive experience by keeping users in the flow zone. Then the second family I discussed, co-creative or computer-assisted creative systems, have the potential to make professionals better and more efficient at what they do. There's already studies showing that. There's also studies showing that sometimes it's not quite the case. It makes them faster, but they make more mistakes in some other domains. In creative domains, it seems to be pretty good, the effect on professional workers. For beginners, it lowers the barrier of entry. Obviously, like I can make composition with MMMs that I can't even dream of making without. And people who use generative systems online probably get a sense of that as well as beginners. And it will eventually provide a better higher level interface for all. Because in the end, what has happened with the creative tasks in general is the computerization of society. And that computerization has been pretty systematic, pretty brutal, and we're still stuck with Windows, icons, mouse type interface in which creative workers are stuck 8 hours a day, clicking on buttons, often in the same order, often in the same software they didn't program. And so we call that here on the West Coast the click factory. And so it is probably a good thing that there's a little bit of smartness being injected in those machines to make this work a little bit less of a click factory. Another issue that I want to talk about, now that we saw some of the pro of why this could be an interesting set of tools and why it's so widely embraced already, so I don't have to convince anyone, the market is doing the work here. But certainly regulators and regulations and safeguards need to be put in place. And so one of the issues that is obvious now, I believe, to most people is this big data issue. The fact that models are trained on possibly copyrighted content. In fact, the model I showed you, the multi-track music machine, is a transformer. It's trained on all of the media data we could find online. Because in Canada, under fair use, as a researcher, I can use data available online for research purposes. Now, when I train the model, the data is not in the model, and so I can sell that model or use it commercially. And this is exactly what all the big commercial companies, Google, Meta, etc., are doing. And the reason why they run, one of the many reasons why they run BIS Research Lab, is to have the right to do that research piece by which they suck all the data for research purposes, and then they exploit the model. So there's clearly a loophole here. And this didn't escape the artists themselves, which are like, no, you can't do that. You can't just take all of my work online and then train a model, including my work, and then sell that model to other people. If I would have sold you that work, you would have paid a lot of money. If you have 6 trillion image in your database and you paid $1 per image, then you can't afford the database anymore. So there's been serious pushback, and in fact, lawsuits are ongoing in California and other places around this copyright loophole. And there's a lot of pushback there. In fact, when it comes to work replacement, but also these copyright issues, that's part of the strike in the US with the actors and the writers as well. So in the lab, we've been addressing this big data issue by trying to propose alternative approaches. We're really interested in small data. And we've been working with artists on a new project called Autolium, which is a neural visual synthesizer. It's going to be released maybe this term as well, if the gods of DevOps and debugging are with us. So yeah, Autolium is a neural visual synthesizer. It's a no-coding interface that allows anyone, but in particular, it's aimed at artists, to use a small data set, maybe 20, 50, 100, 200, maybe a couple thousand, but maybe 50 images as a data set. And with that coding, to be able to train your own model and explore the latent space of that model, explore all of the parameters of the neural network, do some network binding and taking a layer from one network, injecting it in another one, without any coding. I've really access, and so we are interested in giving this tool in the hands of photographers, animation artists. We're working with painters now, visual artists, graffiti, mural artists, etc., and work with them on generating either static or moving images. The entire system is controllable through OSC, so it can be hooked up to tangible interface, and really you can explore physically and then save presets and be like, yeah, I like this place, and you're the artist and it's your data set. And that is very different from using DALL-E or from using stable diffusion. Here you see someone manipulating the latent space on the network live. Some of those manipulations correspond to affine transforms and manipulation that we know, and some are much more abstract into the latent space of possible visuals. Here is an example of an artwork generated when the system was trained with the work of Erika Lapas Jensen, who is a visual artist here in Vancouver, and she was really impressed by the output and how the system would have captured some of her aesthetic, but at the same time produce something completely different. Here is an example. I was saying the system is controllable in real time, of the system generating visuals. This is a piece we exhibited, myself and Jonah Scratch from the Meta Creation Lab in a museum in Kelowna. And here the music is clearly, musical features are clearly mapped to the visual generation, and you will see the type of coupling that we get. So that was a short excerpt, and you can see here using OSC, we have the music really controlling the movement in the latent space and some of the parameters of the network, and that's a really tight mapping, and that's something that if, as someone who is doing music video or VJing, I want to do manually, it's going to be really hard to have that mapping, and so this tool really allows for real-time generation based on the small data set and no coding, and to access new aesthetics here. In fact, if I would edit a video that fast, probably it would make people vomit. But for some reason, the network dynamic has some intriguing and almost analog-looking aspect that we like to exploit. So with those types of systems, really all together, the two families of approach I mentioned, we're entering a new wave of augmentation and automation, partial automation and augmentation of creative interfaces and software. And as each time there is a push for automation and augmentation, and in fact, each time there is actually a serious innovation, it's almost a way to see if there's an innovation, is that there's a pushback, and it scares people, or some people. And here there is no doubt there is a strong pushback, and we are back in a case of the fear of work displacement. And that was also very central in the actor and writer pushback on automation as part of their strike. And, in this presentation already with movement, somewhat with music, with sound design, we saw completely how that industry could be disrupted, and at least things need to be discussed and negotiated, which is happening. And in fact, the US yesterday just released the equivalent of the European AI Act, and it's going to take a while to impact and for them to progress there. But none of that is new in a way, in the sense of the pushback. Each time there is automation and augmentation, we see a fear of technological unemployment rising. In the earliest 20th century, the last large movement of automation and augmentation, because of the invention of the steam engine and the automation of physical labor, a number of machines were invented that automated a number of low-level physical work, and there was a lot of pushback. The Luddites in movement were a movement of skilled English workers wanting to get rid of the machinery that were supposed to replace them. In France, the silk workers in the early 1930s revolted against the mechanization of their work. More recently, still in the 30s, the American Federation of Musicians was spending their money in trying to defend and trying to protect musicians that were playing live during in cinema theaters, and they were replaced by gramophones. And there was some pushback there. Eventually, it was found that in all of those cases, there was a momentary disruption, and then in the long run, there was some sort of improvement of the workers' condition and of the field itself. And the studies we have for the moment regarding the rise of AI, and I'm not talking only about creating AI, but the prediction at the MIT Business School and others have been working on that, and a lot of papers have been released that the current prediction is that indeed is going to disrupt a number of fields for real this time, which is going to be a problem and is to be addressed by politicians and society. But in the long run, it eventually going to, again, even out, and if anything, create jobs and activity. Who is to know? One of the things with the rise of AI is that we all lost a little bit of visibility, and things are moving fast. So we'll see what happens. Now, human societies, on the other hand, are moving slow. So I'm believing that it's going to take a while for those disruptions and those changes to really take place. Meanwhile, new jobs also appear. Prompt engineering was not a thing 2 years ago or 3 years ago. Except if you would follow the Metacreation Lab and you would have worked with audio metaphor for the last 10 years, you would not have thought a lot about prompt engineering. Now you can get trained in prompt engineering, you can get hired, it is a job. So some jobs will disappear, some will appear, things are going to change. And so I think with that, I reach a conclusion here, and I think I talked a little bit about the main challenges and cons that I have in mind, and we need to have in mind in our research. There's big data and the loophole around fair use. How are we going to integrate small data? How are we going to deal with copyright issue? Last week, I believe, there was a very nice talk in the same series here by Jean-Marc Delton that Jean-Pierre Briot invited, that is really unpacking all the issues around copyright, and there's many. It's not simple. The notion of plagiarism, style imitation are complex, because this loophole says that the model doesn't have the data, and the model will never generate exactly the data, which for the most part we show is the case. So our transformer, for example, is trained on existing music, but the likelihood, if you generate more than 2 or 3 bars, that it will quote, that is do plagiarism on the corpus, is very, very, very low. And it goes to infinitely low as you generate more and more material. So the material generated by the system is original, yet they are trained on copyrighted material. Technological employment and its fear. Where are we going to go with that? No one knows. Deepfake and synthetic media may be even more problematic. How are we going to be able to not only tell who did what and what is authentic and non-authentic content, but in terms of authorship, how do we deal with the royalties if I was the author of the model, or I was the author of the dataset, or some of the element of the dataset, or I'm the author of the output, or I'm just a user of a system. How do I untangle the very many layers of authorship? Because those systems are really part of the creative process now as co-creators in some cases. And then finally, the phenomenological dimensions of that for user experience for everyone, for creators who spend a lot of time in front of their computers creating those assets, but also on the receiving end. How will it feel when what we're listening to, what we're watching, none of that would have not been AI generated, would still be enjoyable. I often make the joke that, you know, with the generative AI, we don't need human anymore, and so humans can feel a little bit out of the loop, and it's all about interfacing those systems in ways that is satisfying for us. Otherwise, I can generate my exams at the university exam question with ChatGPT, then the students answer those exam questions with ChatGPT, then we have ChatGPT talking to itself back and forth, and we're going nowhere. So it's really about integrating those tools into our lives. So that's what I wanted to say mostly today, present you those two broad families of approaches of application of creative AIs, which we are already seeing and we see increasingly everywhere. Talk about the evaluation of the systems, in particular acceptance, technological acceptance, and then raise and summarize a little bit some of the challenges and opportunities we see. In the end, technology has continually shaped us. Humans and technology have co-evolved for a long time. At least this is one of the main take in evolutionary psychology out there. And away from the fears of AI taking over, I believe still in the humanist tradition of anthropocentric instrumentalism. These are only tools. They're powerful tools. And it's true that the rise of co-creative interfaces has or will have deep social, political, economical implications. But we should stay in control of those tools and get to decide what tools we develop for ourselves and our futures. In the case of creative AI, I think it will allow us to harness the power of machines to expand and support our creativity. And so with that, I want to thank all of the co-authors that were implicitly or explicitly mentioned throughout the talk here, students and colleagues. For those who want to know more about creative AI and computational creativity, there's 2 online courses, 12 classes each on Cadenze, which I do recommend as a MOOC for creative tasks. I believe that the first course is free. The second one is for pay. If you want to get in, I'm happy to send me an email and I'll send you a code just for this group. And then, yeah, and then these are links if you want to find us online. If you're interested by the conference we organize, I'm on the steering committee of the AI Music Creativity Conference. And I was also instrumental in starting the conference on movement computing, which is now an ACM conference. I want to thank the funding bodies from Canada that is supporting this research, the Conseil for the Arts, as well as the National Science and Engineering Research Council. And with that, I think we will have still half an hour or so for Q&As if you have some questions. So thank you for your attention.
Thank you, Philippe. Well, a lot of information and a lot of thoughts. Great talk. A lot of examples. I already have had a look at the chat, but there's no comment and questions yet, because usually people get shy to start being shy, and usually somebody has to start the process. So yes, Philippe, again, thanks a lot. It's very interesting, and I myself have a lot of comments and questions. So maybe in order to start oh yes, there's a first comment. Excellent. I will translate in English for you from Mila, who's actually one of my previous students from Uni Rio, where we had, remember, you met with her, Philippe. Actually, when we did this this seminar about creativity and AI, and Mila was there. She joined, and she said excellent presentation. Os examples muito very interesting. So first comment, and I joined Mila on my. So maybe just Philippe, just maybe a first very little inline comment, because you in the starting you mentioned the self-organizing maps, but just I will kind of retranslate for the audience if they because in the self-organizing maps are actually a way to have a non-linear primitive principal component analysis. In it's based on neural networks. It's very old, and actually another version that I talked about, just to make for the audience to make the connection, are autoencoders. Autoencoders are doing very similar things, that they extract the abstractions, are joint abstractions, and they also have some there are some clustering algorithms. So I won't get into detail, but just to say that self-organizing maps, that in your first example of system that you mentioned, is part of this kind of large collection of neural networks, artificial neural networks based techniques for analyzing data, not learning from data, not only for prediction and classification, but also for clusterization, for non-supervised. Anyway, it was just a little mention for the. And maybe have a look. Oh yes, there's a question from Bertrand Petit, that you know well also, because we were together in this workshop. So from Bertrand, from your point of view, Philippe, what are the main institutions working on AI in generative music, except Simon Fraser, of course?
Right. Well, that's a good question around the context. And yes, there's quite a number of groups now that are interested in generative music. The largest concentration, and it's also, I mean, everywhere is good quality work, but the largest concentration is at Queen Mary in London. They have a music AI doctoral program with about in excess of, I guess, 30 PhD students working on music AI. And they have, I don't know, 5 to 10 faculty maybe on this topic. And so that's the largest concentration at the moment. Some other major player, if you wish, are Bob Sturm and his team as KTH, where there's quite a lot of action going on there. And there's a few other laboratories, Shlomo Dubnov in California, and then IRCAM has always been involved for a long time now in France, as being one of the player as well in that field. And then something new that is also worth mentioning, and new, you know, in the context of the university, which is a 1,000-year-old type of institution, is the industry also now has a number of major lab, and it can be considered a major, if not the major player. And that's, I say it's new because in the world, or in our world, and in the world of knowledge, in almost any domain you can think of, until recently, the best in the world will always be a professor and their PhD students. But things have changed, and many subdomains now of computer science, and this is, I believe, increasingly true for AI, and the industry is competing with academic labs, and often not just competing, but took over. And in the field of AI and big data and machine learning, this is quite clear. So I want to mention those as well. So Magenta from Google is also, although they seem to have slowed down the music generation aspect of their work, but a lot of the big private companies that run big AI labs have been doing music generation, usually not so much symbolic music generation, although there's been a bit of that with the transformers and the VAEs and all that, but audio generation, because audio generation itself is really, really big, voice, music, and sound. And for that, you need massive amount of data, massive amount of computing, massive amount of engineering. And so that sort of took over. And I mentioned that last category of groups, non-academic groups are there. And it's interesting because when you're an academic, it's almost unfair the way it functions and the way they sort of took over, because they have machine PR machines. Their work is very, very visible, which is something that now matters, you know, the impact of the research. And it's visible in a way that is unfair, for example, to my students, right? Because my students are like, well, we did a paper 2 years ago that are at least as good as this one, and nobody knows about it, right? And so that's been, so for example, probably no one, you know, it's not the case that when prompt-based interface came out, people were like, oh, actually, Philip was doing that 10 years ago, right? It didn't appear to people that way, and so that's something new, but something that the entire community is still unclear and somewhat ambivalent about. Like, you know, how are we going to, in a long-term, interface those big industrial players with the academic world? There's a lot of things going on in that in the music AI field in general, but in this interaction between academia, industry, and the world of practitioners. Yeah. And within academia, what makes it also complicated is that this is an interdisciplinary field, right? So you get the computer scientist, you get the musician and the composer, often different schools within the university. And then you have teams that are trying to bring people together. You need the designer, the people doing the interface, the people doing the testing. And so, yeah, all of those people have to work together in those teams. So I don't know if I answered the question, but yes, those are the main players in that area. If you're interested in keeping track, we have a AI Music Creativity Google group that people can join. There's a number of hundreds of people in there, and we post all the CFPs and some news. The Izmir mailing list is also a good forum to follow things. Yeah.
Thank you, Philippe, and I think you answered well the question of Bertrand. And yeah, I agree. Just Bob Storm is from Stockholm. It's König. It's a university. It's a main leader university in Stockholm. But Bob is from England. And Shlomo Dubnov is from San Diego, UCSD, which is an old player in computer music. And yeah, of course, as you said, even in AI, I mean, not just especially, but generative AI, ChatGPT is coming from OpenAI, which is the industry, and which makes a big, I mean, game changer. So we are, yeah, it's a general problem, which is not especially only about our domain. About AI and art and creativity, but it's hard to compete with big players who have resources, human resources and computing resources, of course, which have, and also they can exploit data from for instance, for all research about evaluation, etc. They can exploit the data about the usage, and it's also very we cannot compete with that. So we need we need to always to find some niche, and to when it's conquered by the big players, we need to find a new niche, and it's part of the It's part of the game, and as you said, audio generation is getting very bigger and bigger. Still, I think, and we are still many to think that this I mean, symbolic information is of course its sense of composition is still very important, and
eventually we might
yes,
get hybrid. Yeah, eventually we might get hybrid systems. But yeah, you're right. It's hard to compete, and also it means that I need to be strategic, and you know, all the faculty here know what I would mean by, you know, I can't put a PhD student on a topic whereby they won't have the mean to really succeed, and they won't have the mean to succeed against Google and OpenAI. And who really has the mean to succeed against Google and OpenAI? So as soon as you know that one of the tasks they're trying to address, then that task is sort of written off as a potential, because I need that task to stay alive for 5 years. You know, if a year later they kill it with a massive neural network, then all of a sudden, and it happened to me to the past, to have to restart PhD students because they were working on something, and all of a sudden it's done. You know, and it's done in ways we couldn't even, you know, dream of doing. Just to finish the first answer of who are the players, I would be sad to not mention all the other intervenants in this seminar series, right? And for example, coming from the industry now, François Pachet has definitely done a lot for the field. And then, and then the other intervenant that Jean-Pierre is inviting are also great people to follow. So yeah, there is a community out there. It's dynamic and it's fast moving. On the industrial side, it's impressive. Maybe like 200 or 300 startups on music AI, like right at the moment. So we're not dozens, but hundreds of startups. So it's a lot. In fact, the number of startups, I don't know if the market is sizable enough to really absorb all of that, but that's the world of startups. There's lots of competition out there, and that's fine. You know, 95% of them will fail, but it's almost impossible to keep track of the new music AI apps because it goes really, 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 really fast right now. And so there is a bit of this exponential moment in which the number of application and application scenario for those algorithms we talked about is really, really vast, and yeah, it's huge. And so so there's a lot of development and competition, and that makes it really hard for anyone to follow, process, digest, and there, you know, form an opinion and think things through, right? Just because this pace of change will have to slow down, like you know, a plateau we need to be reached, because otherwise the flow I was talking about is changing all the time. In fact, if you use ChatGPT, the version might be changing in the background, and so, you know, one day you're like, you want to show your colleague or your students, hey, if you ask that, he would make a mistake, and then you show it, and then he doesn't make the mistake anymore because it's been corrected. And so the models behind, so sometimes the systems change very quickly, and the models behind the system change very quickly. You probably heard about stories of people committing suicide because their girlfriend artificial agent model has changed, and then all of a sudden they forgot a lot of the interaction or things like that. So for good or worse, yeah, things are moving very fast right now. And as Miller Puckett was explaining, with software in general, software tools in general, to become a virtuoso at something and to really form yourself a strong opinion on a set of tools, they need to be stable enough so that you have the time to work your way through. You know, if the violin changed every 5 minutes, nobody would be a violin, you know, a violinist. Like you need 10 years to work your violin every day to get there. Well, the software we're talking about right now, none of them is 10-year-old, and they're changing really, really fast. So it will take time for, you know, things to stabilize, companies to be like, okay, this thing is now stable, it works, it's useful to my workers, let's integrate it. And that's time that nobody has, that make the evolution of AI and creative AI, not just for labs, researchers, students hard, but for everyone as well. And that's generating anxiety. Because right now, for example, there's domain in which it already reached the point, like if you're a programmer, you have to use Copilot or some things like that. It will improve by 20 to 90% your efficiency. It's been shown already, meaning that if you don't, you will be a subpar programmer in 6 months, maybe in 1 year max. right? So there's like these sort of forces that are at play that sort of suggest that everyone will have to use these, and that's where I'm really interested in this acceptance dimension that I discussed today, that I think should be a bit more front and center before we deploy those tools in every workflow out there.
Thanks, Philippe. There's another question by Bertrand, but just before, two very short comments. Yeah, it was important to mention the work by François Pachet, our colleague and friend at Sony Computer Science Lab. And after at Spotify, unfortunately, Spotify stopped the project, and actually, there's big competition between these industry players. For instance, in a way, OpenAI, you mentioned about Magenta, Google Magenta, which was really, somehow a leader. And now, recently, OpenAI with ChatGPT, DALL-E, etc., really took some kind of lead. And just my second comment about the startups, as you mentioned, there are many. Something interesting that I was contacted by a startup in France, which didn't use deep learning, because now like everybody's using just deep learning, and it's important to keep other types of foundational technology, and they are using constraint solving, for instance, and symbolic, and it's very important to keep this, because we who have some knowledge about the technology, we know the merits, and we know this kind of gigantic, really game changer through massive data and computational power, etc. But we know also the limits, so we need to continue, and including in the academy, exactly, not just joining only the mainstream, but continuing for the future, investing in the future. But I will stop here and go back to Bertrand. Second question. I also have lots of questions, but first the audience. Do you feel there are still non-AI actors working on generative music?
Non-AI actors, meaning people that don't use, like you were just talking about the dominance of neural networks and deep neural networks. So for temporal modeling, we used to use Markovian systems and factorial and all sorts of probabilistic machine learning systems, which were at times working really well, but had limitations. And so neural networks has really been good at temporal series modeling, and music is really has both horizontal temporal dimensions and vertical alignment dimensions. So the neural network architectures are really good for that. But I agree with what just Jean-Pierre was mentioning, and there's a vast amount of techniques. And if you follow my Cadence class, I think I go by families, and in a way, generative art was not born with even computers. Like this idea of having the art being a process, and that the process generate an outcome. That's an idea that has been really, really out there for thousands of years. And so dice music and the introduction of chance operations into art making, all of those approach are steps or baby steps toward generative systems. And so, yes, there is a wide variety of techniques that are not qualified as AI that are used in generative music. When Yanis Xenakis in France, the composer, was using probabilistic methods to generate clouds of notes in his compositions, that was completely automated process. In fact, he was one of the first French to access the then I think it was IBM supercomputers in Paris. and using them for his composition. And again, it's up to definitions whether at the time there was AI, because there was him using mathematical process to automate, a task, a compositional task that would have taken a human brain intelligence to do otherwise. And then now we see, oh no, it's just a stochastic method, it's not AI. So, the definition of AI in a way is a moving one that way. But the idea of automating the making of composition, to take just the idea of computer-assisted composition, is not new. It didn't start with neural network, and there's a wide variety of AI techniques that can be used there. In fact, I would argue that there's no AI technique that has not been used for music generation. So, in my class, I teach stochastic systems, then I teach complex systems and fractal for music, lots of work on fractal for music. Then you got chaotic system for music, lots of work on chaotic system for music generation. Then you have grammars and symbolic systems and logics, Jean-Pierre just talked about. Plenty of work there. Then, cellular automaton, and then agents and multi-agent systems. The MuseBot, for example, is an example of a current system, which is a collection of agents. You go on the site, you download a bass agent, a drum agent, a melody agent. There's no AI really involved. They're all sort of rule-based little agents programmed in Max, and you make an orchestra of agents and they play together. So this is in a way still AI, but it's agent and multi-agent system without neural networks. Then you have evolutionary computing, which is still some of the approach in evolutionary computation are not accessible through neural computing, for example. So then there's algorithm in evolutionary computation where we don't have a neural network to do that as well. So there's also non-neural network subfield of AI that are alive, not just because they're a bit different, but also because their affordances are very different from the ones of neural network. So I don't know if that answers the question, but there is no shortage of diversity. And for those interested in that, the Cadence class that I give is really bronzing. I think there's 400 examples and at least 10 different families of algorithm being described there.
Yeah, actually, thank you, Philippe, for Bertrand's question is, as you noticed as well, is somehow ambiguous. So I just wrote on the chat, Bertrand, by non-AI, do you mean purely algorithmic generative systems or system with knowledge but without machine learning? Because they are, as Philippe also explained, they are really a huge family of. It's true that right now deep learning based is the current winner, because basically you don't need to write your rules at hand, being algorithmic or being knowledge. I mean, grammars, etc. So, but of course, the point is to combine human control. So that is some kind of human intervention. You like it better, that you want to control, etc. And something which has been automated. So that's the ultimate goal. But I think I think anyway it's a deep question, and it's and again AI, as Philippe said, and it's a catalog of tools. So it's not just although there's the iceberg, top of the iceberg is currently deep artificial neural networks. There are a lot of other stuff, and algorithmic music is very old. I don't see new, so maybe I take my chance because I enjoy very much the talk, and maybe going back to because I took my notes. Philippe, you said in a way, why you ask a great question. Why would we remove humans from the loop? And but actually, I one of my answer, for greed. I mean, because for for profit, to maximize profit, as you mentioned, for some of the tasks is kind of very basic. I mean, programming will be replaced by Copilot on GitHub, and the cashier taking care of scanning the ingredients, the food, etc., that you buy in a supermarket will soon be replaced by you take something and it will be automatically detected by RFID or cameras, etc. So all this kind of very basic which can be automated will be replaced. There's no, I think, and for whatever you think about it, I think it's not no more question. And I think in the creative work it's the same. That is the kind of very, very basic. That's what, for instance, the strike in Hollywood, and for the les droits voisins, the neighbor rights for the people who are doing translation of some movies. This is at risk. This is at risk. And as Philippe mentioned, on the other hand, there will be new jobs for exactly how to control, how to prompt, how to this new technology to do things better. So it's very disruptive.
I think it's also going to generate diversity. Diversity and I can elaborate a little bit on that. There's 2 points I wanted to make. One has to do with diversity of automation. So a little bit like when we automated the making of objects. So now when you have a glass, a cup, for example, this one is actually, it's written at the bottom, is made in China. So all our objects, all the physical world we live in is produced by automated means for the most part. So 2 things here. First, it means that it didn't completely replace craft. There's still people doing pottery and things like that. And in fact, it did give value to the purely human-made objects. Purely human-made objects are now much more valuable because they're much more rare, and most people, glasses are made by machines. And so now there's this 2-tier system, the machine-made stuff and the non-machine-made stuff. And the non-machine-made stuff is universally preferred in, for some reason, and in most domain and things. The second thing, and when that automation happened, it was automation of a repetitive task in a factory. It's about the value of the automation and the acceptance of the automation. When we first automated things and put machine, but then we needed operators, and the operators is actually becoming a machine itself or herself, I find that was bad automation, right? Now we're talking about a new way of automation where I feel we have the potential for good automation, as in independently of the disruptions it's going to take. Programming, to take just that example, but in general, interacting with the computer is a pain. It's just a pain. Humans are bad at it. It's terrible. You spend 10% doing coding and 90% of your time doing debugging. It's a nightmare. Anyone who has worked with the computer long enough, and I'm taking the example of coding, but it's true for any other computer-assisted task, has had nightmare stories with their computer. Things are getting better, but definitely this fact that now we're going to have AI, little assistants that are quite competent, that work for free, never get tired and do what we want. And instead of, fighting with the missing semicolon, I can just be like, install an Apache server there. And then the system is like, I'm done. What else do you need? And then, oh no, I didn't mean it that way. Do it that way. I need this, right? I need this thing. And then all of a sudden it's going to change radically what a computer is, right? And right now, a computer is a machine that makes human have to tell the computer every detail, button by button, function by function, button they didn't program, click on them over and over, often very repetitively. And so that is the experience that I hope those systems will improve. So again, and there's already studies on that, making professional therefore work faster, but possibly improving the quality of the work, because all of a sudden when you program with Copilot, you spend way less time thinking about the syntax and way more time thinking about problem solving, breaking down things in sub-problems, exactly the type of stuff that computer science professors like me want to teach their students, right? The syntax is interesting, you need to know it, but this is not the art and the soul of programming and software engineering and algorithmic thinking. So I think, like not every automation and augmentation has the same potential. And I like to measure that potential, not only in the greedy gain that we're going to do. Jean-Pierre, you're right, there will be some there, and there will be some mistakes made because of that greed, I am sure. But looking at the human experience that the automation changes. And I can, I was naming some automation from the past where I think it didn't change the human experience for the best, but I can see that some of the automation and system we're talking here have at least the potential to really change it for the best, if they did not already. If you are an English second language student in my university, you love ChatGPT, because all of a sudden your English can be on par with the Canadian, first having English as first language. So it just completely changed your world when it comes to the time and the quality, the time it takes to write a text and the quality of your output is completely different. Now, it also means that, again, deepfakes and authentication, like how can I know when I read something that is not written by an AI and is genuine human writing? Well, right now, at this very moment, I can't. But a lot of people are working on that. Yes, point out those two things, because the greed is one part that we're going to gain upon, but hopefully there'll be other gains, or at least there won't be loss of human experience because of the greed, right? So that's this balance that I'm looking at.
No, I agree. I mean, of course, it's a short-term greed is one of the engine, but fortunately, this is not the only one. Otherwise, the human being would be in real problem. But yeah, so it's already a bit after 6. So maybe some comments, and for not just for you, Philippe, but also for the audience to join the dots, and also maybe 1 or 2 questions. So comment, yeah, you mentioned the great talk, another great seminar by Jean-Marc Delton. It's interesting because you mentioned this, the fact that there's a bias against computational creativity that even I didn't know about it, that David Cope already under this. And now I would really recommend for those of you, audience, it was not yet listened to the talk, the seminar last week by Jean-Marc. It's very interesting because he also mentioned that, and one of the problems exactly that there's the community of graphic designers there's one designer who made some design, some graphic design, who looked artificial, and he had to defend himself, saying, "No, I did it with my own hands and without an AI tool." So now you need to prove that you are not a machine, or as you mentioned, there should be some kind of logo, some kind of like the Creative Commons, some way to and also to mention the source. But I have a question also for you about also private commented that I really enjoy your I didn't know about a recent paper about the acceptance about MMs and with the joint with Cubase with Steinberg. So I will read it with very much interest, because this is important to have this kind of study. But so I think the interface, the designer interface is very fundamental for the ease of use, as you know, of course. And somehow there's always this balance between beginners and experts. Experts, they want more refined control, more controls, and the beginners, they don't. And it's not just, cutting, just showing free controls, and if you're expert showing 100 controls, it's not that, because the beginner wants the point is to have the right controls, even if there are only 3 controls which have how to say it? Well, I think you got it. That is which have control enough. I mean, it's not just reducing the amount of control; it's just changing the focus. And for instance, I'm just thinking maybe to explain. I did my PhD long ago at IRCAM, and there were the computational music synthesis model which was used was a singing voice, which a great advantage of it is that has only a few parameters. With few parameters, you can change a lot expressingly the output. When you have additive synthesis, for instance, you have zillions of parameters, and you change one, and the change will be very. So this is a difficult question, I think, to have how to find this kind of adaptable control, which somehow are more how to say, more wide for beginner and more reduced and not just cutting the amount of control. So I don't know if you have some idea.
Since I started computer science, I started learning that at the university in the 90s. I always was promised, in a way, this idea of adaptive interfaces, like, this idea that user interfaces would be adaptive. And in fact, maybe you start with an interface, but as you use it, the controls that you use the most come to the forefront and things reorganize. None of that ever happened, right? Because it turns out having an interface change on you is just a nightmare. And so people would go into the third submenu 3 levels down 60 times a day, because at their job, that's what they do, and maybe they'll find a shortcut and things like that. But adaptive interface so far has not been a thing, and I regret it. And so we are, in fact, have to balance either different version of an interface, or, there's this like advanced pan, and then you unlock like a myriad of parameters. And those are yet design issues that are well known in human-computer interaction. But what AI, specifically generative AI, makes harder in this context is that unless you have like really a beginner model like Ava or things like systems in which you select a mood, a style, and it makes all the work for you, when you have this back and forth of co-creative interaction that I was describing today, it means that you're doing partial generation, and partial generation in the context of something bigger. And so think about in-painting of like a few bars, or in-painting of the part of an image. Well, if I give you too much control, I can actually break the system in a sense, because you can ask stuff that are not meaningful. So if I let you mask the note that you really want, but then you got it wrong and you're not in key, and the note you mask are actually needed and the one you let go won't fit, then my neural network is like, sorry, but nothing musically fits here given the request you did. Or the network will actually be bended and be like, I'll do something, but, and so if you want to resample, so it means that if you give too much control to a user in the context of the generative system, what we noticed is not only the user would get confused, but the user could actually sort of break the system by making a request that does not make sense in the context. And the neural network, interestingly, is often smart enough so that if it doesn't make sense, he's like, well, I would rather have silence, and he would generate silence, or things like that. And then the user is like, well, it didn't work. And then all of a sudden you're like, well, actually it did work. It's just that your request didn't make any sense, musical sense, in particular. And so you got these moments where for some control that we have, parameters that we could expose, you would have to assume some musical knowledge. And then the question is all about exactly those levels of how much musical knowledge do we assume by who. When we work with Steinberg and others, it was very interesting to see how they do that internally. And often what they do really is to give as little, independently of whether you're a pro or a beginner, because the majority of the licenses will be sold to non-professional, they give as little control as possible. And controls are made in such a way that you can't break anything. And so even a completely, dummy persona of a user would not be able to break things with the control they give. So that's sort of the design policy that internally I sort of can observe without telling too much about how they do things. But yeah, these are really complex problems. And so right now we have done this experiment with a very minimal interface, and with Steinberg we're doing a much more rich interface with a lot more control, and rerunning professional to see if it should change things quite big, and running beginners on both simple and hard interface to see. And what we want to evaluate in our case really is that it makes professional faster and better. And there's a lot of other studies now showing that is the case in other places, like translation, like plenty of other tasks, some creative, some not creative. And interestingly, it also means in some domains, in medicine, in law, for example, they found that some users would be very good at using the AI and would get better quality result faster. Some would be less good and would get results faster, but not of the same quality. For example, in some domain, they found that people using AI make more mistakes, because then you really have to be careful that the AI is right. So your attention needs to be somewhere else in a way. So we want to study that for professionally makes those type of differences. And again, we want to try to see if the experience though of doing the work is improved itself, because that really matters. If you can now compose music fast, but you don't like the process anymore, and it's a pain to open that software every day, because you have to, because you want to be efficient, then it's going to be a nightmare and sort of, the scenario, the Orwellian scenario that everyone is afraid of. And so that's why we want to test that now. And then for beginners, it's a bit different because it's lowering the barrier of entry. 90% of people who buy a music software, they would never finish a track. They bought the software because they wanted to be a musician. They wanted to learn and get into the music, or they have a little bit already, and so for those people, there's real interest from the industry of seeing therefore they can really, in a way, your retention, or you transferring someone who buy a license into someone who actually makes music, if that ratio can be augmented by those AI system, then that would be fantastic. And it seems that in visual art and in other places, it is exactly that what's happening, right? It's just people can do with ChatGPT, or with DALL-E, or with Midjourney stuff that they can't do on their own. And in that sense, it's sort of lower the level of entry and sort of raise the bar altogether at the same time, and for sort of everyone. And that's the second aspect of raising the bar, that is not putting some sort of serious pressure on anyone who decide not to use the system, right? And that's where it's going to be complicated to negotiate. Yeah, for a number of profession is going to be hard, and internally for each of the of those professions to decide, okay, do we jump on AI? Do we jump now? Do we go progressively? How do we do it? Are we early? Are we like? I can see that everyone is stressed. Same for a composer. Someone busy who is like, okay, am I like doing my next piece this week, or am I like spending time learning the stuff that Philippe is talking about to see if there's anything there for me? Like, when do I decide to go one way or another, right? Because not everyone is following everything all the time as we try to do, and even for us it's hard. And so that's another thing that is going to be really hard, is to manage with adoption and wave of adoption. Of course, the youngsters and some of the people that are more influencers or enthusiasts do follow, but the bulk of people is always a little bit behind, and so it's going to take a lot of time for those workflow to really penetrate our society, and that's true in the artistic field as well. So in the end, I'm giving a talk later this month on what is going to change for art education as well. So there's education in general, then there's art education, and then there's the art world and the experience of the creators, the experience of the audience. And then what's interesting as well that we don't talk so much about, because it's going to take time to really be recognized and emerge, is what, if any, new aesthetics, new quote unquote cultures, are going to emerge from those practices and those tools, not just amplifying, helping, or become tools for existing aesthetics, cultures, and practice, but what new practice could be there. For example, in generative music, one practice that is still gaining momentum is live coding. This idea of building a generative musical instrument in real time. by coding it, right? So that definitely is a new practice. In terms of new aesthetic, I was talking about the neural aesthetic. There's almost a visual art school now, you know, a bit like there was like the various art movement, you know, the pointillist and surrealist and abstract cubist, etc. Now there is, you know, the neural aesthetic whereby there's a group of artists that are using in particular GANs, and then you can sort of recognize in the aesthetic of the work that this is GANs, you know, this is not oil painting. And so the same way you can recognize an oil painting because it is oil painting and it looks like oil painting, independently of the content, right? So there is all of that is also interesting for cultural anthropologists, you know, to look into as it unfolds. Yeah.
And it's very interesting, important to have exactly evaluation studies about the key question of evaluation and also acceptance. So your work is very, I mean, line of work with your students and your colleagues is quite important in that respect, because otherwise the tendency to the street just to make new products, new prototypes, and just, you know, because it's like for the scientific system that is there's incentive for creating something which is supposed to be new paper, new, etc., and not really taking care of what's the life of this, you know, what does it mean, what's the kind of long life study of it. So it's it's important to keep an eye on it. And I think, just going back to, Bertrand Petit, he confirmed that yes, when he said non-AI, he meant deep learning, non-machine learning based system, because it's really a big trend. But I think we'll stop here. I still have comments and questions to make, but let's keep for next time. And as I said, I plan to do on the last, I think it will be on the 12th of December, try to gather everybody and exactly to have some kind of wrap-up discussion to try that I will try to summarize what and to not close the debate, but at least to have some kind of, you know, lesson, some kind of things to go back home with. And with this, I really want to thank you, Philippe. It was a great talk. A lot of very interesting how do you say in English? Instigating, or it's
interesting investigations.
Yeah, examples and great work about evaluation and acceptance, which is fundamental. And I will have a look at Autolume, because I think this relation between visual and music is of course is fundamental. The scores, the very ways of notation. Anyway, so lots of fun and interesting things to talk and to work about. And so I will have a last check if there is some more. No, I think there's no more comment, no more question. Philippe, thanks a lot, and for your great talk. And so you will meet Nathan. It's a private information. My current and PhD student who worked with, interacted actually with Philippe and Jeff Hens about MMM's models. And in the Izmir conference, which is one of the big musical computation conference in Milan, if there's not flooded that you just told me. No.
We see the situation. Hopefully everything is good for Milan in the next few days, but it seems that they're underwater right now. So we see this conference is carrying on.
Milan will become the new Venice.
All right, thanks a lot, and thank you everyone for attending today.
Thanks a lot, Philippe. Andre, you can stop the transmission and the president of CESAR, which is a big institution.
I was planning on going to visit him and Jaber in Recife. I think they are.
Oh, yes. It would be great.
I'm still in contact. I'm still in touch because Recife and Nantes, where I'm going.